Hello and welcome to Bevy Basics episode 3. In this episode I'll be giving a quick overview of components and how to interact with them in your game or application. Basically in Bevy, components are synonymous with structs and they are representative of basically the smallest unit of data that you want to attach to an entity. So in my example that I have here, I have an example component that I'm using as a flag to make sure that I only interact with entities that I'm directly making here. Otherwise, I would grab any entity that had a combination of the components that I'm looking for. Then I have a speed component, which is just a new type struct that wraps a float, and then a direction, which is just a vector3 done the same. In my example code here, I have a spawn balls function that takes in a commands, materials, meshes, and the size of the world resource. Then I'm generating an RNG that will let me add some noise to my scene that I'm making. I'm then creating a mesh of an isosphere with a subdivisions 2 and a radius of 1. And this is where we get to the bit where you actually start interacting with components. So I'm creating my values by randomly generating numbers for my 10 spheres that I'm going to spawn. I then insert my material, which is then derived from those parameters. So the speed affects the red, the size affects the green, and the blue is completely random. I then spawn a bundle. A bundle is a collection of components that are related to each other and may depend on each other in a certain way. When I spawn these, we'll individually insert my mesh component, my material component, my transform component, all into the same entity without me needing to individually call insert on each of them. Once I've spawned my entity and its bundle has been inserted, I then individually insert my speed, direction, and my flag component onto the entity to allow me to access that data and associate it all with the same object in the world. I then have another system that runs every frame. With this system, it requests using a query, which is your primary way of accessing components, all entities with a transform component, a speed component, and a direction component that also have a component example. I'm requesting access, which is what the first part of the query is, to the transform mutably, the speed, and the direction mutably, whereas I'm only requiring that it has the component in the other section, so it won't prevent any other system that requires that component. I then get a resource of time and a world size resource, and from there I will start manipulating the components. As you can see, the transform component, I simply iterate through the query and manipulate them as the structs that they are. There's no special requirement for editing a component. It is just purely a struct that is a representation of the said data. This does result in my new types requiring to be .0 so that I can access the first parameter. But I could also, like a transform, use named parameters like its .translation and then continue to act on it as a struct. Basically, anything you can do to a struct, you can do to a component. And because I'm getting mutable references, which is the only way that queries will let you access things, which I'll go into queries more in a future video, but because they are all references, any manipulation made to the component will effectively act on the component itself. And then finally, just a system down here to show that you can query just sort of different things at different times is I have a query for the speed that will more or less speed up or slow down the balls every 2 seconds. It'll either double their speed or halve the speed depending on which phase it's in. When you create a component in Bevy, you more or less declare a struct and then derive component on it. It is also possible to add the additional attribute component storage equals and then sparse set or table. This changes how the component is stored under the hood. A sparse set being a component that may be on a few but not a majority of entities. And a table, I believe, is the equivalent of a dense set, which is a component that you expect to be on most, if not all, entities. So a name would be something that you'd put into a table, because just about every entity will have a name, whereas a rigid body would probably be a sparse set, because not every object in your world will have a rigid body component attached to it. And that's more or less everything that there is to do with components. The components themselves are fairly simple because it's an abstract concept. It's not until you start getting into what components you want to use that you need to actually start considering your design. The recommended advice is to more or less break your components down to their atomic level of anything that is inalienable from anything else should be the same component. Things like speed and direction should be separated into two different components, because you may want to access something's speed without regard for its direction and do a function on it, like I'm doing here. And you may want to access something's direction without accessing its speed. So splitting those two components is better than having a physics component that contains both speed and direction, because with this example, the two functions can't run in parallel because I have badly designed the first one that it requires mutable access to direction and speed, because it needs both. But if I was to do a function that used the direction and flip the direction based on the transform like I'm doing here, and a separate function that moved without needing to edit the direction, the speed switch function and the direction switching function would be able to run in parallel because they don't share anything in common. And then the move ball function would be able to run because it needs both. But I've condensed them into one function, not necessarily the best practice. I'll now demonstrate what this code generates in an actual application, so that when I run this, I end up with a world of size 10 by 10, because that's what I set up. And then the balls will just bounce around, changing speed every 2 seconds. And this is a very simple program that, if you want to expand upon it and try something yourself using the code that will be available in the description, you could try adding them changing color as they change speed, or changing speed based on something other than just a 2-second timer flipping back and forth, and have their color proportional to their speed, or position in world. You could also add functionality like changing their size or something based on their speed. These are all functions that you could add and should try doing, just to get a feel for manipulating data in individual systems, so that you get an idea of how the data is separated into its own functionality, like the size and the speed and the color are all their own components, and so can be manipulated by basically pairing them into parallel systems that can all run at the same time. Another idea would be to make them so that they actually collide with the edge of the sphere instead of the way I'm doing it, which is just the middle, which basically means that the bigger spheres will go outside of the zone before bouncing back, simply because they are larger. But that's just a quick example of components and how you can separate logic using components to split your bigger concepts into individual units that you can then manipulate on an individual level. So give that a try. Do leave any comments on anything you think I forgot, and I'll put updates and maybe make an additional video. And like, comment, subscribe, and I'll see you in the next video.